So we'll start from here. We have this question. Consider the universal set R to be that, and its subset X to be equal to. Okay, we've been given that subset X there, and Y as well, and we have Z there. Then they tell us to find the following sets and display them on the number line. So we must find these sets and we must display them on the number line. So in order to find these sets, what you must do is, let's get a graphical representation of whatever this is. Okay, somebody has their mic on. Okay, so alright. So let's put this information which we've been given this question on a number line, such that we see what they are talking about. So we have the universal set. So the universal set is given that way. So this universal set goes from negative infinity to positive infinity. So like that. These they keep on going, negative infinity to positive infinity. That's how this the universal set is. Then we have these subsets now. So we have subset X, which is negative infinity to 5 there. Then it's closed at what? At 5. So let me say let me use a different color. My 5 is here. So if this is my 5, then I'll say here at 5 it is what? It is closed. So when I write, I'll shade that there. Then this continues to go. Okay, it continues to go. Let me write this nicely. Continues to go all the way there up to negative infinity, like that. So this continues to go. So this is how the set X is. Then we have the set Y. So set Y, it's at negative 3. So we can say negative 3 is here. Then if we say negative 3 is there, okay, if negative 3 is there, we can put this also in a different color. So we'll have, it goes from here 3. So from 3 all the way up to 7. So you can say our 7 should be somewhere there. So if we have that, say our 7 is here. So at 7, okay, so at 7 it is closed at 7. So here at 7 it's closed, so I'll shade that in. Then at negative 3 it is what? It is open. So I have open there. So that's my set Y. Then I have my set Z. So if I say I have my set, this is here, I say this is 10. So 10, then it's going all the way up to what? Positive infinity. So this is going to be from here all the way up to that side. This is how it's going to be. And here it's open at 10, if you can see from there where Z is. So this is how what they are talking about kind of what looks. So this is our Z. So this is what they are talking about. Then they tell us to find we must find X complement minus Y complement. We must find that. So now we can simplify that to be X complement intersection. So here, because of this minus sign, so if I have, let's say I have X minus Y, so this is written as this set difference can be written as X intersection Y complement. So in this same case, if I rewrite this, I'll get X complement intersection Y. There's a complement on Y there, but I have to put another complement. So the complement goes with the complement, and I just remain with Y. So it's X complement intersection Y. So this is a simplified form of it. So now, if I look at what I have, when I look at this graphical representation that I have here, so my set X goes from 5, and it's closed at 5 all the way up to negative infinity. So it continues to go all the way there. So now what will be in my complement. So by definition of complement, you are saying all those elements that are not a member of what of those of that set but sit in the universal set. So our universal set is the entire set of what of real numbers. So now then our set X starts from 5 here, it's closed at 5, closed at 5 all the way up to negative infinity. So the complement of X, meaning what, will go from 5 all the way going to positive infinity there. But then since it's closed here, meaning that 5 is part of X, meaning it won't be part of the complement. So meaning X complement is going to be equal to, so it will be open at 5, then it's going all the way up to infinity like that. So this is not a fixed point, so it goes like that. So this is my X complement. Then I already have my Y from the listed from what I've drawn here. I already have my Y. So I can, so for it, I write both of them. Let me just write it down here. So I have this, then it's going from negative infinity to positive infinity like that. Then let's say my 5 is here. This is my 5. Then so from 5, an open interval at 5 going all the way to positive infinity like that. This is going to be my X complement. Then I have that my Y complement, my Y is from 7. So 7, and it's closed at what? At 7. So 7 all the way up to negative 3. Let's say negative 3 is here. So all the way up to that side here, where negative 3 is, and at negative 3 it is okay, so it is at negative 3. So from there all the way up to negative 3, then here there's an open interval at negative 3. So now you check where do these, so if you look, there's this here where these both what intersect, these two sets intersect. Now I need to get, so that is what is going to be my X complement intersect Y like that. So from here my my 5, so we see that 5 is not part of the Y complement. So 5 meaning is cannot intersect with this set Y here. So 5 cannot intersect with the set Y. So meaning at 5 there we're going to have an open interval. So it will be open at 5 like that. Then we see that 7 is in Y, and 7 is also in X complement, and because here it's closed at what, at Y. And also we see that this set X complement goes all the way up to what, infinity. So meaning the number 7 is part of that set. So meaning at 7 there we're going to have that it is closed like that. So this is what is going to be our intersection, and that is the answer to what, to our first question, which is 5 7 like that. Are there any questions here? Okay, I don't have any questions. Okay, so let's move on to the second part of it. So I'll erase this, erase all this. Okay, just remain with a bit of that there. So now going to this part of the question, so that one I have that Z intersection, so X minus Y, then complement like that. So from here what I do is I have to what, simplify this. So this is intersection, then what's inside here is X. This is the difference symbol, which can be written again as intersection Y complement like this, complement. So I'll have that. Then I can distribute my complement. So intersection inside the bracket there. So I'll have X complement, then this will change from intersection to union, then I'll have Y. So I'll get this. From here I can also what, distribute my intersection over this. So when I distribute I get X intersection Z intersection X complement like that. So this is part, then union, then Z intersection Y. So I have these two sets here. So I can easily identify from this diagram that I still have here where does this intersect. So I have Z here, Z is in yellow, then I have Y in green. I can see from here there's no intersection. These two sets have no intersection. So this other side is just the empty set. Then I have the other side where I have Z intersection X complement. So we said our X complement. So our X here, our X is from 5 to is from negative infinity to what, to 5, and it's closed at what, at 5. So then our X complement, as we earlier discussed, meaning is going to be open at 5 all the way up to positive infinity, like that. So this is my complement. Then where does this intersect? So if I was to write my complement, let me sketch it here. Write it. So from 5 here, it's going to be open at 5, then it goes all the way up to infinity, like that. Then where do these intersect now? So where does this X complement intersect with this set Z? So I have from, so here this is my 10, from here, like that, this is what will intersect, like that. So this is where my intersection is what going to be. Now I see that 10 is not part of what, of the set Z. It's not part of the set Z, meaning it will also not be part of this intersection, meaning to be open at what, at 10. So it will be open at 10, then this goes all the way up to what, up to infinity. So that's my intersection. Then I can put this together now. So I have the first part, which is this now, Z intersect X complement, which is just 10 comma infinity. So I have 10 comma infinity, like that. Then union the empty set. So we're bringing all these together now, union the empty set. So this will just give us what, 10 comma infinity, like that. So this is what our answer will be for this second part. So that is just going to be equal to 10 comma infinity, like that. So this is our answer. Any questions there?